Hello
Right.
everyone. This is Sam from Neo Smart Economy. Today we are glad to invite Jimmy from R3E Network to introduce a new native Oracle series today. Hi Jimmy, please introduce yourself first and start your workshop.
Hi, thank you very much for your kindly introduction. My name is Jimmy. I'm a core developer of Neo, and I'm also the co-founder of the REE network, which is a real-time Oracle solution specifically for Neo. And today I'm gonna give a workshop on the new Oracle native Oracle system. I'm gonna explaining why we need what is Oracle and why we need Oracle and why Neo need a native Oracle systems and how Neo's native Oracle system works. So first of all, what is an Oracle systems? And everybody knows that if you really in the area of the blockchain and you have tried and used the blockchain stuff, you might already know that when Satoshi Nakamoto invented the blockchain, he specifically designed the blockchain as an isolated environment where you don't really get the access to the outside world data once you get into the blockchain world. For example, if you want to transfer data to transactions on the blockchain, you can only interact with the data that is already on the blockchain, or you can interact with data that is in the same blocks with you. The problem with this is that though it's very secure, I would say that there's no secure things in the world, maybe than this kind of design because it just blocks you from outside world. The problem here is that in such an isolated environment you get less very rare connections with the outside world. Once you wanted to do interactions with something that requires that it depends on the real world data, it becomes impractical in the existing Oracle design. I'm sorry, in the existing blockchain design. For instance, if you are doing some kind of smart contract things, such as you wanted to order the flight ticket from decentralized applications, you can't do that with the existing blockchain design because you don't get the price data from the price data of the ticket of your flight ticket because the flight ticket is the data that comes from the real world, our Web2 world, from the companies where they defines and decides the price of the ticket. If you wanted to use that data in the blockchain, in the smart contracts, it's impossible because no one gonna provide that data in a secure way for you to use it. So in the past, this design is totally fine because we just do with blockchains to do transactions. For example, with the bitcoins, we just transfer bitcoins from here to there, from your friend to your family members or your things and stuff like this. It's very simple scenarios. So it's fine without outside world data. But problem comes when we have the smart contracts and much more complex and much more functional smart contracts uh, that provides more and more services for us to use. This when this kind of things comes to our scenarios. For instance, when we talk about DeFi, decentralized financial stuffs, when we talk about decentralized gaming stuffs, when we talk about NFT stuffs, we're gonna need to do trade. We're gonna need to do trading with a much more complex scenarios, situations, environments, and we can't just rely on the on-chain data. For example, if we want to do decentralized financial stuff, so we might need to trade the stuff without that does not with the price that does not already exist in the blockchain. For example, if you want to trade your Neo to Ethereum, or you want to trade your Neo to Bitcoin, or you want to trade Bitcoin to Neo, maybe there's no price data already exists on the Bitcoin on the blockchain. Actually, this data does not exist. Um, what if you want to do that in a decentralized exchange or decentralized financial applications? Here comes the solution. We need the option data but we can't get the option data. No, we have something called Oracle systems, Oracle protocols for us to provide that kind of option data to the blockchain. The most famous projects of the Oracle things is the Chainlink. I think some of you might already heard it and maybe even used it to do trade. Even if you don't use it, you didn't use it, you might also use some services that depends on the on the Chainlink solutions of providing the price feed or data feed to the on-chain solutions. Existing solutions on the Chainlink, they provide two types of Oracle solutions. The first one is they keep syncing the data, the price data to the blockchain. For example, they keep syncing the Bitcoin price, the Ethereum price, or Chainlink price to the blockchain. They don't care about whether someone's going to use it or not. So they just make sure that on-chain data is as accurate as possible to the to the option data. The other solution is that when people use it, when people wanted to use some kind of data, people make a request from the blockchain, and then they monitor that request and then the process the request option and get the data, and then send the data back to the to the blockchain with the callback function, such that they can give back the data the smart contract requires to execute. That is the existing most famous solutions of the Oracle solutions, which is Chainlink. But the problem with Chainlink is that, first of all, Chainlink is a third-party solution. It is independent to the blockchain solution, and if you read the Bitcoin papers or the Ethereum papers or the early age smart contract blockchain papers, you might realize that what people, blockchain people, blockchain developers, blockchain researchers trying to avoid the most. Why we work so hard on this is that we wanted to get rid of third-party things, and we want to do transactions from the first from one to another, from another to me directly, like a P2P network. We do not want to trust the third party. We do not want even the government. Why would we trust on Chainlink, the third party solutions? So that's the first and the biggest problem of Chainlink. Another problem with Chainlink is that they're gonna need you to own their coins, so to process transactions, so to process requests, which means you not only have to own you not only have to get the access to the blockchain native coins, for example, Ethereum on Ethereum or Neo or Gas on Neo. You also have to own some kind of links, so you're gonna have to pay for their services with the two different kind of coins, which is very complex to use. And the third problem with that, with other third-party solutions, the developers of the of the blockchains don't really own controls over their projects. They don't have access to their code. They can't customize their services. For example, if we are Neo and we want some kind of new functioning be added to the Oracle services, we can't do that because we have negotiated with them because we don't own them. We are separated entities. We don't control them. So that's the problem with the existing solutions, and that is also why we need a native Oracle. A native Oracle means it's not a trusted third party, right? It's native and it's controlled by the community. So that is Oracle stuffs, and the new Oracle stuffs is that we try to build an Oracle solutions that can not only provide option data to the smart contract that enables our applications, our decentralized applications to provide to get access to the outside world data in a trusted way, in a trusted manner, but also make the most suitable for our new blockchain without relying on any kind of third-party stuffs. On Neo systems here, and you can see on my shared page, web page here, we have the new we can Oracle services, or we can just call them Neo native Oracle services. If you know the new consensus algorithms, you might know that new has a voting mechanisms where you can, as long as you own some new tokens, you can vote for council members for nodes to become a council member. So we can take a look at the page here. Here's the where the voting results. We have 29 candidates right now, and we vote for the council members. The top 21st knows that acquires the votes tickets becomes the council members. So the council members, this means the council members are decided by the whole community. And as long as you hold the news, you can become part of the voting process. You can become part of the decision making processes. Currently, there are close to 33% of NEO has been voted in this process. I'll see this is even higher than the United States voting for president. So, with these council members, the trust coming from the whole community, the council members has the powers to decide who becomes which members becomes the Oracle nodes, and also to be also I need to mention that here that the consensus node are also nominated by the council members, although in another way. So the trust of our native Oracle services comes from the council members, and the council members' trust comes from the school community. So as long as you own some NEOs, you become the part of the process. No third party decides who provides the Oracle services, but the whole community. This is no third party services. I will see this might be the very first Oracle services that does not rely on third party trusted third parties. Since we are native services, Oracle services, we do not need other kind of strange coins to power the systems to run. You can just pay the service fees with gas, with the gas tokens that you own. You get distributed when you hold the new tokens, and it's also flexible because we controls it. I'm sorry, it's not we controls it. It's NEO community controls it, and NEO communities decides how and what the Oracle should be like and how it works, and what functions it should provide. Though I'm working on the third party real time Oracle solutions. I would see the trust in our projects is way less than the trust and the native Oracle's services here NEO provides. And the NEO Oracle systems works in a way that where people makes a request on a smart contract, and then we respond to them with the consensus. This is how our NEO native Oracle systems works. For security, the committee revolves these things is just for security stuff, so we can just skip it because to make sure that no Oracle nodes can make it collude things, can collude each other to cheat on the system. NEO systems works in a way that people can. It's basically depends on the relies on the developers to relies on the developers to build our native our Oracle services into the services, because it is the smart contract that makes a request. Here I have an example where you can take a look at take a glare of how the system works. NEO has provided a lot of Oracle solution examples, demos where you can take a look at how to use them. And I think in the previous workshop sections, you have learned how to code with the NEO code NEO smart contract with Java, with Go, with Python, and those are very excellent projects supported by the new communities, and they're very excellent developers has produced these tools. You can also use that kind of languages to develop them, maybe even either and faster than C Sharp. But here I'm gonna use C Sharp that is provided by the new core developers NGD to maybe to as an example. Here's the Oracle's examples where demonstrate how our Oracle services provide the data. When users want to use make an Oracle request, you have to call the smart contract method, some kind of method, and in the method you're gonna have to make an Oracle request. This Oracle request here, the Oracle is a native smart contract that has provides some basic functions. For example, the make a request. Here's the smart contract here. It processes transactions. It processes requests and handles requests, and then make events with the Oracle nodes where Oracle nodes can monitor these things and make the corresponding request response on the request. And it also handles the process of taking service fees and taking charging the other kind of extra fees from the users, and make sure our Oracle services is transaction fee sustainable. Here the request is sent to the Oracle smart contract with parameters of URL, where URLs can have different protocols. Right now we have support on the HTTPS, and we also have the support for the new file system. These two protocols. If you have joined the previous workshops, you might know that they have demonstrated how to use the new file system. And the URLs can point to the JSON files where JSON files that contains the values and the data that we use. With those structured data, we're gonna need a filter, which is a JSON pass to tell you how to tell us actually. To tell the Oracle services how to get the data from the JSON file, because we can't just return the JSON contents, the belong to the JSON contents back to the users. We can just provide the simple values to them, because we have a maximum size of the value we can provide. And their callback functions. Callback functions are the names of the functions we wanted the Oracle contracts to call when our Oracle services finished the respond on the request. So it's the name of the callback functions. It should be exactly the same as the things we have in the smart contract. And the user data are the other parameters that user specifies when they wanted to use after the Oracle node responded the data, the requested data, and of course gas for a response, because Oracle services are not free. You're gonna have to pay for that. Not only just the services fees, it's also because Oracle is gonna send transactions, and Oracle node is gonna cost the transactions are gonna cost the transaction fees, right? So you're gonna have the users gonna have to pay that in advance. And after the Oracle nodes processes the transactions, process the request, and get the data, and make the request, the response transactions, and they can make transactions to call this the Oracle request, the Oracle smart contract, and then the Oracle smart contracts can further verify that smart contract transactions, and then cause the finish functions to call back our the user smart contract with the user callback contracts and callback methods, and as well as the data and the response result. So in that way, we finish a smart contract. We can finish the the Oracle request, which is very simple and very efficient to use. And I would say it's even much cheaper. It only charges like a quarter right now. Considering the price of the gas right now is only $2.6. It's very cheap and affordable, I think, for most people to use. And aside from that, there's something we can make further discussions on here with it. The first thing is that let me take a second. When the Oracle node makes a request, makes a response, responding the request, there's possibilities where we might not be able to handle the user request properly, because the user request might contains request that is not that is not processable at all, or maybe the data the user request is not accessible, or maybe it's too big, or maybe there takes too much to the servers, their service is too slow to process. Oh, by the way, here we also wanted to highlight that we as an Oracle services, we do not guarantee the trustworthiness of their server. We only make sure that the data we provide, the data we get, the data we feed to the smart contract are the data that we get from the server that as the data source provided by the smart contract. We as an Oracle service, we do not guarantee the trustworthiness of the data. It's possible that the data source makes false data. It's possible that data source cheat on us, but that is the responsibility of the smart contract developers to decide whether they should trust the data source or not, because we do not have control on the data source. We only get data and then return and verify that and then return it back to the smart contract. That's it. And yeah, and let's go back to this response code. We have different types of status code for the response. The first one, of course, is the success. We have successfully processed the user request and successfully reached the consensus and returned the data to the smart contract to process. And of course, we charge the money, service fees for that. But it's also possible the user has provided the wrong URL. A smart contract has provided the wrong URL where we cannot process it. For example, they might not use the HTTP, which is not supported by us because it's not a secure protocol. We need a HTTPS. So once we have a HTTP in there, we're gonna have to return protocol not supported error status. And also this possible consensus cannot be reached because Oracle nodes, we have multiple Oracle nodes to make sure the liveness and secure and safe of the user data. But it's possible that different Oracle nodes get different data from the same server, because from the same data source. It's possible because there might be some time gap between different nodes reaching the data source, and the data might already changed. It's possible. And that will make the system unable to reach consensus on there to agree on each other's data. It's possible. So once this happens, we will not respond any data to the user, but respond with the consensus is unreachable. So here also comes to another very important problem and of the existing Oracle systems, which is the Oracle services provided right now contains very high latency. You're gonna have to expect very high inaccuracy of the existing Oracle system. It's not just the Chainlink, it's not just the other some kind of Oracle services, not just the Oracle native Oracles, but all existing Oracle systems have this problem. But data all existing Oracle systems provides is extremely. It's not extremely, but it's not accurate. You're gonna have to take that and accept that for a while until our services is online, because currently we are developing a real-time Oracle system that can provide 100% accurate data. That is what is REE is a real-time Oracle systems. And go back to this status is consists unreachable. If the data is different, they're required by different nodes is different. And now phone indicated that required URI is not accessible, it does not exist at all. We can't get anything from there. It's empty. So it's a zero. It's an empty status. And timeout means there's slow response or something else. The problem the network is to uh, uh, is not able to be reached. So this timeout status forbidden, which means that we don't have the right to access there. And the response too large, which is exactly the why we need the JSON parse. JSON parse we need to proceed, but the response too large is another is also similar, but another problem, which means and not just the data. The data we can get from the JSON parse is too big. It's the JSON itself is too big for us to process. For example, someone might provide a 1 gigabit of JSON per file. How are we supposed to process that on our server? It's going to consume a lot of energy, and the network bandwidth is very costly for us. It's going to destroy our service. And insufficient funds means that the user didn't pay enough money, enough gas in advance for us to process their transactions. This is not likely to happen, but it's possible. Because we have the Oracle service, we have an Oracle contract which will handle the money charging process to avoid these constraints. The content data type not supported, which means it might not be able to, it might not be a JSON file, which means we cannot proceed with the JSON pass. And of course, there are other different types of errors that we can't be identified right now. There may be some errors we don't even understand and need to be handled properly in the future. So that's the Oracle response code. With these things, you can understand what happened to your Oracle request to your data request with our services. And aside from these things, we have to go a little bit deeper with the things which is the JSON pass, because when we get the data from the servers, we specifically require the data be the JSON file, the JSON format, because we're gonna need to process the data. If you are data of different types, for example, if you are image data for JPGs or PDFs or something like that, we're not able to process it. We're not able to get the data, get the text, to get the content from the pictures. So it has to be JSON. But when we have JSONs, the problem is that the JSONs are structured data that can contain different layers and contains nested things. It's hard to be processed. So when we process with JSONs, we need the JSON pass things to process with it. The JSON things is developed. The JSON pass here we use is developed by Eric, and he has developed it properly, which supports basically all the functions the formal define define the JSON pass should support. And we have tested cases here for basically all considered situations where you can take a look here. If you prefer to have a better understanding on how the JSON pass works, it's separated to the smart contract things because it's inside of the new JSON projects here. You can get it from the new from our GitHub new project. Here you can see those things. You can just take a look and run it. You can see it's all right. And aside from that, I can to be better and either read and we can go to the pages where we have documents precisely explain and describe how to use them. Here's this thing. Here's where the symbols use the JSON pass explained. Basically, all the JSON pass things has to be started with these dollar signs, to make to indicate the start of the JSON pass, and then we have the at, indicating the current object and elements. There goes down all the way you can just check them one by one, making sure you understand it properly, such that your smart contract can parse the data, the servers, from the data source properly. And aside from those suggestion paths, once you would parse that, there's another thing that I mentioned about the size of the response things. We have a precise limit on the um on the data we can process. It's the size of the response data is actually the maximum value of the unsigned short, which is um that's this 65,000 or something. It's maximum unsigned short. It's about 46 kilobytes, 46 kilobytes. That's basically pretty much of it. Let's check it for further steps. As to the Oracle request, let's go back to the consensus things of the Oracle things. When user makes the request, they have to get send those parameters, specify those parameters to the request, and telling the Oracle nodes how to use them and how it works. And this is basically what we already explained and discussed. Here we also, in the document pages, we also have the explanation of the filters, different filters. You can just take a look of this document here. And yep, that's basically pretty much of the Oracle stuffs. Yep, yes. Thank you very much. That's the explanation of the native Oracle things.